tune and then they're like, welcome to Radio Lab or whatever.
Hey, what's going on, everybody? So on this episode, I sit down with my buddy Carl, who works up in Portland, Oregon at Portland State University, PSU. And this was a fun episode to record because we actually did it in my house, in my little office room, which is a rare occurrence for the show because usually the way these are done is recorded through the computer. I'm setting up a call with someone and I'm talking into my microphone and they're wherever they are talking into theirs. But yeah, in this case, we were hanging out. Carl met my wife and got a cup of coffee and a water, and we walked on back here to the office and sat down and had a nice chat, which was fun. And I think it made for a good talk. One other interesting thing I noticed as I was editing this one and putting it together was that I think I was observing myself playing a sort of a different role, sort of a goofier role in this. I don't know if that'll come through to the listeners, but it might be just because Carl's a very smart guy and he's describing things that I know so little about. We're talking about outer space missions and some other crazy stuff this episode. And so I think I just sort of slipped into this role of reacting and sort of giving these responses like, whoa, sweet. It may have been that I was just listening to a lot of Joe Rogan that week or something. But anyway, I think this made for a good conversation. I think it came out well. And let's see, you'll notice at the end that Carl, I asked for an answer for the famous Drake's equation, the percent likelihood of life being out there in the universe, and Carl resists. He doesn't give me an answer to the question. He resists giving an answer, but I think that what he does give us is so much more than that. And so have a listen, have some fun. I'm glad you're here, Carl.
I'm glad to be here.
Yeah, this is fun.
I'm excited.
So we met at a conference, at a science communication conference,
Mm-hmm.
April of 2019.
Yeah.
And I remember a little bit from that conference. There were a lot of people from different disciplines. I think I was one of the few social science folks. It was more geared toward, I don't know, was that your impression too, that there were a lot of medical science, life science?
Yeah, it definitely felt that way. Definitely a lot of medical and like the more, I don't know, I feel weird this term, but like hard science folk were there. Yeah, I definitely had the same feel.
Right. And yeah.
Do you use a different term?
Well,
what do you do?
Well,
how do you make that distinction?
Because, right, there's actually, psychology, for example, it sort of gets defensive at, we want to be hard. So
yeah, I know. That's why I don't like it.
Right. I mean, I'm not, I'm not easily offended by things like that. Don't take it myself too seriously. But I mean, it's almost kind of, how like marginalized communities will reclaim a term. Like we used to be called queer, but now we own that term and we love it.
Mm-hmm.
I don't know if that's a good analogy or not, but
I just like the distinction or whatever, or like, the way it's distinct, the distinction happens. I feel the same way about like when people talk about like hard and soft skills. I'm putting air quotes. But I recently joined the outdoor program. I think I told you about, and there they refer to them as technical and human skills. So it's like technical and human, whereas being human is very important. I like that terminology more, I would say. But yeah, I just like, if there's I'm trying to find another way of making those distinctions between those.
I like that too.
General fields.
Yeah.
But like that's more appropriate or accurate.
Yeah, it's more of a description of what skills are instead of like most important, second most important.
Yeah.
Yeah.
Exactly.
Yeah. I mean, I get it. I
Hmm.
understand sort of like if you're studying a quote unquote physical world, or if you're studying a world of human beings,
Hmm.
like what's the but
Yeah.
um but that's neither here nor there.
Hmm.
We met at that conference. We're here now, and I remember you telling me a little bit about what you did.
Yeah.
It sounded pretty cool. One of the reasons I called you up and was like,
Mhm.
"Oh, I gotta get Carl on the show." Um, and so, yeah, I know you're fresh off your 3 minute thesis, silver medal victory.
Yes, yes, that's accurate.
So yeah, so you don't have to give us the 3 minute spiel, but how do you describe what you do when
Mhm.
someone comes up to you on the street, or if you're talking to a an uncle at a?
Mhm.
I
Well, there's a
mean,
couple different, I guess, ways that I do it. I can do the short version or the little bit longer version. My short version is um, I am working and my group is working on developing different technologies and techniques to look for microbial life in outer space or on other planets or moons in our solar system. So that's like my short and
I like
sweet
that.
to the
I
point.
like that. What was that, 10 seconds, 12? That was
That's
good.
like 15, 20
That's
seconds.
good.
Like
That's good.
probably, yeah, it's really short and it kind of like gets people just in general. And then usually people will then ask
Uh
questions
huh.
if they're interested. I mean, at that point, you kind of get the concept.
Right.
And if sometimes a little bit longer, I'll go into more of like just like how I'm excited and like what I get to do for my research is to think about whether we're alone in the universe or not,
Mm.
and how when I first think about this question, I really think about like how vast and expansive the universe is, and there's estimated to be 100 billion galaxies in the universe and in the observable universe,
Jesus.
and like 100 billion galaxy or stars on average in each of those galaxies.
Mm.
And
I
so
can't
just
even
thinking about,
comprehend.
yeah, just thinking about those numbers and then thinking, like statistically, the chances are just astronomically low and that there isn't other life out there.
Uh huh.
And assuming that life is like likely to form. And so,
Right. Any kind of life.
yeah, any kind of life. So I'm, of the mindset that there is definitely life out there. And
Uh huh.
so, there's other people looking for life out there in other ways, sending out signals or listening to signals for
Mm.
signals. But the universe again is so large and like spread out, and if you don't know where to send the signal, you're kind of just
Mm.
sending out everywhere or listening everywhere, you might
Mm-hmm.
there's like a small chance you might actually get anything.
Sure.
And so then what we want to do is actually we think life is very very likely to occur, so then we might like look in places in our own solar system, thinking other lineages have arisen here. And so
Wow.
we have what is known as a holographic microscope, which looks at an entire volume of liquid, whereas most microscopes just look at like a single slice. And so we
Sweet.
don't have to, if you would go into outer space, you'd have to, or like send a signal from Earth to like one of the moons of Jupiter, Europa, let's say.
Mm-hmm.
It takes a certain amount of time to send a signal there and back, and to like get those microscopes into focus takes some time, and then you might lose whatever was in focus. It might have moved in or out of focus. And
Mm-hmm.
so
Mm-hmm.
this allows you to like record a whole volume,
Nice.
which is a nice thing about this type of microscope that we have built.
Oh, you guys, have you built
We,
the first
we've
one?
no. There have
Okay.
been other holographic microscopes. We
Okay.
have not built the first microscope, but we have a holographic microscope, and that's kind of like our main microscope that we're using. We have a few other ones, but the one that I've been working with the most is the holographic microscope.
Sweet.
Mm-hmm. So
Wow. So there's a lot of ways to look for life. You can send out sounds, and I think you guys are taking volumes of liquid.
so yeah, there's lots of different ways to like, definitely not sound, because if you like, sound doesn't travel through space because there's no air particles, but like light, so you can use light or
Mm.
radiation to like look for those signals. So if there was like some sort of advanced civilization out in space, they might be sending signals
Mm-hmm.
on purpose or maybe accidentally, like the whole somewhat it's depicted a lot of times in television of like aliens picking up video recordings of like early television from the
Yes.
Earth and thinking that's what Earth is like or whatever.
Yes.
And so like we are sending those signals out randomly on accident kind of, but also we are also sending some signals on purpose. But so if aliens were to send them towards us, or advanced life forms, um and they knew where we were, we could listen or look for those signals, hopefully.
Mm.
Um, and other ways, but then if we're going to go out into our solar system or out into space and actually like look for things, there's lots of different ways we could try to look for signatures of life.
Hmm.
And the way that we want to do it is look through like motility. We want to see if we see things moving.
Hmm.
um and there are things that might be moving that aren't life, and so
Hmm.
that's why you can't just say, oh, that's life, it's moving, it's a signature. It isn't actually like saying this is for sure life.
Ah.
And so we here are like collecting lots of samples from lots of different extreme environments. So places that have either high or low temperatures, high salt content, high or low pH.
Hmm.
Those kind of conditions give extreme environments. Again, I'm putting quotations because they're
Mm-hmm.
extreme for humans, but not for other life.
Mm. Mm.
And we're thinking that those would be, much more analogous to like other places in our solar system that we might be going and looking for life. And so we're looking there, and we're recording videos of these microbes in these locations and trying to look at how they move and see if we can kind of come up with some sort of picture for how life is actually moving here on Earth. And so when we go somewhere else, we kind of know what life, how it moves. And so
Okay.
it's using that as an analogy or an
Ah.
analog,
Very cool.
um,
You're matching up that they kind of
type of
like swirl
motion.
around a little bit. They go this way, up and down.
Yeah, that's the kind of general gist of it, definitely.
Okay.
And we want to try to like make sure we're not confusing that with like regular like the hydrodynamics of like these small systems, and different things like Brownian motion, what it's called, just like kind of
Okay.
random back and forth motion.
Interesting.
um
Does the field have a lot of false positives in where people sort of think, "Oh, we think we saw it," and other people are like, "No, no, man, that's not the way it moves." That's just a
so there is this, and I don't know it well enough. I need to read into it a little bit more again, but I remember there was some mission NASA did, or it was associated with, back in like the 80s or something like that, maybe 90s, um where my boss has told me this story. Jay Nadeau is her name,
oh, cool.
and NASA is just kind of like almost embarrassed to try to go and look for life again because of this. Where somebody thought they saw something that looked like life, and then somebody reported it somehow, and it all got out, and everybody's like, "We found life," and then it wasn't, and so it was
Oh
this
no.
big like embarrassing moment. I wish I had more of the
Yeah,
story,
yeah. Well,
but so definitely there has been this like, yeah, false positive has occurred in that sense of like on the little bit of in the public eye. But in terms of like actually like looking, right now at field samples here on Earth, by eye, we're humans are really good at pattern recognition, and so by eye we actually, for the most part, happens very rarely. But sometimes it can still happen.
mm-hmm.
But we're trying to have it so we can have automated tracking. We have a program that's we've a grad student from Caltech wrote that we are using, and we work with him um, to like automatically track the microbes, and that has a little bit more of false positive record, I would say.
Okay.
I think its accuracy there. He wrote a paper where he did an experiment, and the accuracy was somewhere around a little over 90%
Wow.
accurate. So there were some false positives there, but it was pretty accurate.
Wow.
It was somewhat in a controlled system,
Uh
so it's
huh.
not like out in like
Uh huh.
the natural environment,
Uh huh.
which always increases those factors of
Sure.
uh, that you're likely to get false
Sure.
positives. But yeah.
That's pretty cool, though.
Hmm.
And I bet that this machine recognition can sift through so much more data than the human eye sitting there in front of the computer.
Yeah, exactly, and that's the idea, is because most of the time we have, and have done it some too, have to go and like, okay, that's a particle, and you have to do it for every single time slice.
Wow.
And you have to do it at sometimes, if you want to do it in 3D, every single Z slice. So it's like it's built up. These 3D holograms are built of multiple Z slices or Z planes, and then also time slices. So there
Wow.
can usually, most recordings are under 1,000 time frames,
Mm.
or slices, and then it depends on the
Mm-hmm.
number of Z slices, somewhere
Mm-hmm.
between, I would say, 15 to like 50,
Uh-huh.
maybe 60. And so if you have to go through all of those by hand, it just takes forever.
Uh-huh.
And so yeah, that's the really nice thing about this.
Look at what it hits on and
Hmm.
go back through it.
Yeah.
So how, I mean, it seems like kind of a big deal. Like when I collect data, we
Hmm.
send a survey out online and we get our 100 or so responses back that day, and
Hmm.
then we're on with analysis.
Yeah.
Uh but for y'all
Hmm.
sending something to Europa and back,
Hmm.
that seems like a big deal. How many samples can you get, and what does that look like?
So we're definitely not really close to like any sort of mission right now. So NASA sent out a call for proposals um this last year, and on it, the original call for proposals, there was space for uh uh imaging uh device, and we the idea is that it would be something that we are trying to get on there, that would be the space for our apparatus.
Gotcha.
um but that, as of right now, I think that mission is set for 2024 or
Okay.
2022, as
Okay.
so it's a little down the road.
Yeah, it's a little
So
down the road.
we don't really know exactly what that would all look like. I think that's somewhat a little out of our hands, but my assumption would be um, that they would be able to collect samples. So it depends on where they end up going,
Hmm.
or where, if we end up going to Europa, let's say. There is up to, I think, estimated between like 17 to 80 something kilometers of ice
Hmm.
on the surface of Europa's ocean, which is all just a big ocean, is
Hmm.
what is theorized. They don't actually know for sure, how much water is
Hmm.
underneath all this
Hmm.
ice.
No one's ever been there.
No, I don't think so.
Right.
Not as far as I know. No, not yet. Um, and so the whole getting down to the ice is like kind of, or underneath the ice down to water would be the biggest issue. But like there's other ways of getting samples. You don't need to go all the way down. They might just collect some ice and then use some more mechanism maybe to heat it up, or maybe just look inside the ice um
Gotcha.
itself. So there's lots of different ways that this could go. So our group
Ah,
is our group is kind of hoping that NASA or somebody at some point will be using this technology for this purpose. But we don't actually. We're not like, oh, we have this. We're on board. Like our
gotcha.
device is going here.
Gotcha. And
Yeah,
it would be a part of this larger mission where your sample collector would be on a some piece of machinery that can drill down and melt through ice. I mean,
possibly.
okay.
That is one possible scenario. So this summer I have an internship with JPL,
Hmm.
and they
Who's
have
JPL?
JPL, Jet Propulsion Laboratory.
Sweet.
It's associated with NASA. It's this weird entity. I don't exactly understand completely like the
The
structure of
org
its
chart.
association with
Yeah.
NASA, but it's associated with NASA, and also it's like funded through Caltech
Hmm.
University. But it's like half of a government agency, but half it can also like contract out and stuff. So it has a little bit more flexibility.
Cool.
And so I'm going there as an intern to work with this postdoc from Georgia Tech. His group, I forget the name of the group, something habitable planetary. I wish I could remember off the top of my head right
Hmm.
now.
Hmm.
But his group, they have autonomous submersible vehicle.
Sweet.
Yeah, so what they have been using it for is, going out into the ocean, and specifically, I know this fall they're taking it to Antarctica,
Hmm.
and they're gonna go look underneath the ice sheet. And so,
Wow.
yeah, so that's like kind of a possible scenario that these devices could be used. They don't have all the technology and the know-how, I think, currently to actually be able to drill down through the ice and know that they're going to make it after a certain number, a distance or whatever. Because I mean, when you need to, if you're gonna do this mission, you're gonna be like, we need to basically know that we're gonna get through the ice.
Yeah. Yep.
Otherwise, we're spending these millions or billions of dollars on
Sure.
this thing that,
Sure.
like,
Thus, all the testing ahead of time. Let's
mhm,
do as much piloting as we can in Antarctica or in a lab setting. Get
yeah,
everything
hmm,
sort of squared away.
definitely, yeah. There's a lot of different stages that any sort of NASA mission has, and you have kind of like this generic. I don't know exactly how all the stages are split up, but basically the generic of like testing in the lab, testing in the field here, and then there's the kind of mission ready testing where they like send it to some sort of facility where they like make sure that it can withstand the radiation and also the violent shaking that the rockets like incur on like liftoff. They basically put in this giant shaker and shake all the equipment to make sure it
Oh,
doesn't like just break apart.
wow.
Um,
Wow.
and so those are kind of a
Yeah.
generic version of the stages, I guess.
Yeah. Yeah.
At least based on my knowledge, that might not be completely accurate.
Sure, sure. Yeah, I mean, it seems like a pretty thorough vetting process. They want to
Yeah,
make
they
sure.
definitely have a thorough vetting process.
Gee, where's the radiation coming from?
The sun.
The sun.
Yeah, so the sun. So our
Damn it.
atmosphere, yeah, our atmosphere protects us from all this radiation from the sun. But when you're out in space,
Once you get out of
and
it.
then also not just the sun though, because Jupiter itself actually produces a lot of radiation.
Huh.
I'm not exactly sure all the underlying mechanisms of that, but yeah, I was told that Jupiter. So if you go to Europa,
Uh-huh.
you're going to be incurring also all that radiation
Wow.
from Jupiter,
Gotcha.
and you need to make sure that whatever you're using can withstand to those things. So like when we're trying to look for life, a lot of ways that here on Earth you might like try to identify certain features or certain life, use dyes. And we're making sure that like dyes that we want to be using can actually withstand and still work and attach to like biological parts of whatever there might be out there. We assume it's all going to kind of be carbon based. We're kind of making that assumption. It might not be
Mm-hmm.
true. Probably
Mm-hmm.
is though.
Mm-hmm.
And so these dyes will adhere to these carbon based life forms. But if
That
for some reason you send it through all this radiation and then the dye doesn't attach anymore because it's been altered because of the
ah,
radiation, you might not be able to see it.
there
And
goes your
so
mission.
again, the mission is like, well, what was the point of that kind
Uh-huh.
of thing? So yeah, we have to send it through all these different levels of
Wow.
testing.
Yeah, yeah. Seems
Hmm.
like a lot of prep work, but obviously important to go through all that.
Yeah, definitely.
And so we've been using Europa as an example, and is that because that's a good candidate place for life? People think Europa.
Yeah, definitely. That's one of the big ones. Because of the fact that we're very fairly certain that there's going to be a lot of water underneath all that ice.
Okay.
And I don't know exactly how they've determined all of it, but you can actually see kind of fracturing and like the movement of these kind of sheets uh, due to kind of like because the gravity of Jupiter actually causes Europa to like squish and move, and that like puts crack in the ice, and you can kind of see that on the surface of Europa, all these like scarring that
Hmm.
they have
Hmm.
correlated it to this kind of
Mm-hmm.
motion, and so that's why they say that it's all ice. Or
Hmm.
that's my understanding,
Mm-hmm.
anyways.
Mm-hmm.
Um,
Wow.
and so yeah, so because it has water, because we know life, we're basing everything we know of like what type of life we're looking for based off of life here. And so we know life here is made out of carbon. It needs water. It needs an energy source. And so we're looking for places that have water, and that's kind of like the biggest one right there. And so that's a big one. Another one is Enceladus, which is a moon on around Saturn. And then,
Hmm.
I mean, a lot of
Never
ones.
heard of that one.
Yeah, it's
Oh,
less talked about, but
yeah.
it's of the moons in the solar system. One of them. I mean, it depends on like where you are, like your how much you know about the solar system and like the objects in it. But it's like one of the more famous moons, I would say. But definitely,
Hmm.
Europa, I would say, is first after our moon.
Hmm.
Um, but then
Wow.
also, obviously, a lot of people talk about Mars too, as an
Mars I've
option.
heard of for sure,
Yeah.
but it sounds like people are going after moons more than planets here.
Yeah, well, it's because we know that there's ice there and there's like
Okay.
large amounts of it, and we assume there's large amounts of water, and so whereas like
Ties
Mars,
to the water.
we see there's very much we have
Life.
seemingly a lot of new findings have come out actually indicating that we think there are some possible places that are water. I don't want to say that there is for sure water, but like there are people that have claimed that there is water there now after some recent discoveries.
Wow.
Um, and then there's obviously a lot of uh, you know, you can see kind of the rivers and the features that clearly there was water there at one time.
Mm-hmm.
And so then that indicates that at some point there was at least life there at one point, probably.
Mm-hmm.
Um,
Mm-hmm.
and but now who knows?
Could have been millions of years ago. Could have been.
I'm sure there's somebody out there that has a number
Uh huh.
of like a range, but
Uh huh.
yeah, I don't know exactly, but it definitely could have been. It definitely was not hundreds or thousands of years ago. It was at least
We didn't just miss it.
yeah, it was.
Okay.
Well, depends on what just missed you mean. I mean, human
Yeah.
lifetime definitely we didn't just miss it, but maybe geologically, yeah, it could have been a million
Gotcha.
years ago, which is like in a geological time scale isn't too long ago.
Wow.
Um, but I don't really know the number, I guess.
Hmm.
hmm something side note. This is like separate to all this space and microbes in space kind of
Spit
talk.
it.
So there's this holographic microscopes is also talked about being used for possible identification of microbial life for health purposes
Hmm.
because supposedly it's possible to become very accessible if we improve the technology and able to be used very remotely by people that might not have the experience or the needed experience to work a microscope
Hmm.
that is how it is today or whatever. So the grad student at Caltech had when I was talking to him, he was talking to me about wanting to utilize this kind of in the health field, and
Hmm.
you could be using this in places that are like much more off the beaten path, places that there aren't as many hospitals nearby, like Doctors Without Borders kind of
Huh.
thing,
Huh.
and helping them.
And
So there's like a
so,
lot of different like ways that this technology could be used. It's not just that it's going to be for finding microbes in outer
gotcha.
space. You could use it for lots of different things.
Gotcha. And the technology
hmm
itself is a system that can sift through quantities of data looking for signatures of life.
So, I mean, that is what we are gearing it towards.
Mm-hmm.
The technology that I'm referring to is the holographic microscope itself. So
Okay.
it just makes a recording of whatever's in this like little volume,
Okay.
and
And in a health context, that could be taking someone's bodily fluids.
yeah, bodily fluids, or like they're drinking water and kind of like looking for
Oh,
sources or something like this, and so then you can look for microbes and see like whether they're infected or what they're infected with, and if you can identify you know what their
gotcha.
source is or like what they're sick with, you can then help them mitigate or get rid of the sickness more easily.
Very cool.
Yeah,
So
that's
this,
my understanding. That's also, again, that's
right,
not what I'm focused on. That's just like another
right.
path that this technology could be
Sure,
used that
sure.
I'm not really a part of, but
Right,
I've
but
heard
I'm
of.
sure you know these microscopes very well because as grad students, we have to get down and dirty with
Yeah, with
the
the
techniques.
Yeah, I would say I know it somewhat well. I am still learning, but I have learned a lot about them, and I definitely know my fair share.
Very cool,
Mhm.
very cool. That's a neat offshoot. I didn't know
Mhm.
it could be going in that direction, but
Yeah.
it makes a lot of sense.
mhm. I just like to always like science to me is an amazing tool and technique for lots of different reasons, but a lot of times people want to know what this is going to be good for humanity, like
Hmm.
how is this going to help us,
Hmm.
and part of me I identify with that thought concept as well, but then at the same time I know that like sometimes science for the sake of science or for the sake of research leads to things that down the line just like makes massive impacts on people, and there have been time and time
Yes.
again examples of this, and so it's always good to keep in mind like, okay, this is what we're focused on, but this has like so many more um avenues of potential that you could take this down.
Yes.
hmm
Yes. No doubt. Yeah. You don't always know how something's going to unfold around a corner and then become useful in some unanticipated way.
hmm
Do you think of what you're doing, the first context, the
yeah.
looking for microbial life, as science for science sake, or do you think of? I mean, I think it's such a big
hmm
question that it almost doesn't seem so abstract and sort of knowledge for knowledge sake. It didn't strike me that way. The medical application is obviously
hmm
more life and death here and now,
yeah.
but um I don't know. Do you think of what you do as science sake, basic science?
um so I would say somewhat. I think it's a mixed bag for me a little bit. It's a little bit of
Mm-hmm.
both, a little bit no.
Mm-hmm.
I definitely think the biggest draw for me, I mean, is just intrigue. So like in the sense of like why I'm doing it, I think so.
Mm-hmm. Mm-hmm.
But again, this technologies that like we're working with and developing, have other or avenues that can be taken. So I like see the other reasons to do it,
Mm-hmm.
as being very applicable. But I really like one, just like the idea that other life is out there, but like what type of an effect. So I also believe that this has an effect on humanity, or it will. So
Mm-hmm.
if we at some point know that there's other life out there, that it didn't start with us, or we're not the only ones out there, it'll change people's perspective of the universe and like of ourselves. We'll have
Big
to
time.
ask ourselves, like, well, if we're not alone, like what does that mean about religion, humanity in the future? Like, why are we here? What is our purpose? Like these big questions that people are always asking ourselves will be like altered and shifted. And I think humanity in itself, a lot of people around the world, hold a very view that we are unique and we are special. And I think this will shift that away from it. I think we are a part of this universe, and like somewhat you can maybe make a distinction of like this thing called life, and we are not unique in life, and we are just part of it, and we don't get to like dominate or rule over life, but we just need to like survive, and we are dependent upon each other, and
Mm.
we are not special
Mm-hmm.
is the big part. I
Yeah.
think a lot of people think we're special, and I think that is a flawed um road to go down.
Yeah, yeah, and it does influence your fundamental conception of who we are, what we're doing here,
Yeah.
and getting that perspective shaken up by the discovery of life on other planets.
Mm-hmm.
Yeah, that'll affect people's day to day.
Yeah, and so I think it will have an effect on people's day to day, in some way. I just have no idea how. Um, People might be angry or revolt. Who knows? But
Sure,
I hope it would be for the better.
sure.
Hmm.
So, so when you say that you're sort of driven by the intrigue of this,
Hmm.
did you watch Cosmos as a kid?
I did not watch a lot of the Carl Sagan
The Carl
Cosmos.
Sagan, the OG
No, I
Cosmos.
didn't watch a lot of it. It
Huh.
wasn't really on. Like so, like I didn't have. So my childhood television, we had the old school, like kind of like weird antenna that wasn't a satellite. It was like an antenna,
Okay.
and we had
I
the
forgot you
knob.
grew up in a small town. You
Yeah,
grew up in Midwest.
and yeah, Midwest small town. But like, I mean, my parents chose to have it this way. We could have had TV if they wanted. But we had the dial to change the station, because the satellite thing would turn. You would like turn the satellite and it would pick up different stations by turning. It was, I don't really understand it fully, but yeah. So we didn't have a lot of stations most of my childhood.
So,
Um, so it was very limited,
uh-huh.
until I got a little older. And then I didn't. Yeah, I still haven't watched a lot of them. I think I
Mhm.
would like to at some point go back through. But I've watched plenty of science documentaries. I've watched all the new Cosmos,
Oh,
um,
the Neil Tyson.
the Neil Tyson, yes, ones.
Wow. Well, it sounds like you were interacting with space firsthand. Instead of watching Cosmos, you were turning this dial and the satellite,
Yes,
so you
yeah,
didn't need it. You didn't need that.
yeah.
That's pretty cool.
Hmm.
If you could pinpoint, where else this intrigue came from, were there moments or experiences that you think shaped it?
Mm, so I think this is like a threefold answer, probably. Well, we'll see how if that number changes here in a second or not. But I guess my intrigue with like outer space. Um, I grew up again like in a small town, and we did a lot of traveling as well, a lot of camping.
Hmm.
So I spent a lot of nights out underneath the stars, and I think in one sense probably say started there. And then also like growing up in a small town, there's not a
Mm-hmm.
lot of light pollution, so you could just see
Mm.
thousands of stars. It felt like,
Yeah.
and
It's a good old fashioned Calvin and Hobbes moment. Yeah.
yes,
Looking
yeah.
up.
And like I remember growing up, and like you can see the Milky Way, where I lived in Michigan.
Whoa.
Yeah.
That seems rare.
Um,
That seems rare.
I saw it last night too. Out by Oak Ridge.
Wow.
Yeah.
Oregon's got some views.
They
We
do.
got
Yeah.
some.
If you get a
Yeah.
little ways away,
Yep. Yep.
I could see it faintly. I think where I grew up, you could see a little bit better, but not much. But yeah, so just like looking out at the stars. But then also, I did watch science documentaries as a kid. That once we got beyond that, turning satellite or antenna, um, what was it? I think it was just called The Universe or something like that. There's like a series
Mm.
on the Discovery Channel
Mm-hmm.
at the time when the Discovery Channel was more about discovery and science than what I think it is now.
Mm-hmm.
Um,
Yeah, whatever that
yeah,
may be.
whatever it is now, I know. I don't know. I'm not even sure. I
I
just
think
feel
it's
like
a
all of
reality
the
show. Yeah.
probably that sounds about right.
Yeah.
But yeah, kind of starting with that, and then my family or my siblings, especially, I have two older brothers that are both very science heavy, and I'm the
Cool.
youngest of five.
Cool.
And so I like gained my general science love for science through them, I would say. And then just watching a lot of sci-fi shows. I just
Nice.
just like all
Nice.
those things kind of added together. I don't think there was a single moment.
Sure.
But the interesting thing about like how I got interested in this research, I actually came to school thinking I was going to be doing different research.
No
This
way.
is not my plan. And um, through powers beyond my control, somewhat, I would say, the people that I thought I was going to be doing research with, no longer had funding,
Okay.
and or there was another group that I thought I might have done research. I had like my main group I wanted to work with, which did research in batteries,
Hmm.
and then there was other groups there that did research in solar cells, because I wanted to do research that helped advance technology and ways to improve our energy crisis and the whole climate crisis that we're currently
Okay.
in.
Batteries, solar cells.
Yeah.
Yeah.
And so that was kind of like where I thought I was going to be at. But then, yeah, things just didn't really work out. And then I met Jay, and she was new to PSU, and I was new to PSU. And um, she was told me her project, and it's like, wow, that sounds really cool. And so like I'm interested, and this is really engaging, really cool topic, and I really enjoy the work. But again, like I was saying earlier, 6 months out, I make plans and they're never quite what I
You
think is
never
going to
know.
happen. And who knows where this will take me. I'm interested to see. I'm enjoying it. I'm having fun, and it's a really cool topic.
What more could you ask for? That's
Yeah.
great.
Mm-hmm.
Being a graduate
Exactly.
student. Carl, well, last question for you
Uh-huh.
is, so now that you're out here looking for microbial life, working with Jay,
Mm-hmm.
um, what percent chance would you give it? So correct me if I'm wrong, but the famous Drake's equation that
Ah.
people talk about, I don't know if that's more of a
Mm-hmm.
pop science thing than a science community recognized thing,
Mm-hmm.
but I remember a little bit from college that it was a sort of a 10%.
Mm.
Was that what Drake's equation came out to? 10% chance that there's life out there?
So there is Drake's equation is an interesting kind of uh thought experiment, almost, you might say, because he has built in all these different parameters of like, okay, the number of stars in the galaxy and the number of galaxies in the universe, and then like the number of planets per star system, and like it has to be this close to the sun, and these different things. It has to be this size
Mm.
planet, or it has to have water, and like the chances of that. And he has all these different parameters, and you can adjust them in different ways, because we don't know the answer to all those parameters. We don't.
Gotcha.
Um, and so there have been people that have put the numbers in and gotten very high percentage, like close to 100%. And there are people that have put in different numbers and gotten things, and they've reasoned out, both sides have reasoned out why their numbers are these things, and they've gotten really, really low chances. And so
I
the
like
Drake
that.
equation doesn't really give what I would say results that are gonna give you any satisfactory answer. Like it could go either way.
Hmm.
I think it's a cool concept, and I think
Hmm.
it's down a path that maybe could be utilized in the future somehow. I don't
Hmm.
know, but
Hmm.
so
But
long answer or short answer is I don't know what the percentage is.
yeah, yeah.
And the Drake equation doesn't exactly help me answer that. I would like to think it's high. I have a gut feeling that it's high. That there is other life, and other life in our solar system even, but I don't know. I can't. I don't think I can give a number to it.
Sure.
One thing I would like to say, though, I think this is very important for people to keep in mind, is that like there is this, we as people going to these other places, we have microbes on us, like, right, you like, we're all over, and so we've sent missions to Mars and we've sent missions to the moon. We have, on those missions, we have sent microbes are on Mars almost certainly because of us
Oh,
now.
fuck, that's
And so
right.
we've contaminated that planet probably to an extent, and like those microbes might have gotten there and couldn't survive and died. That's a very likely chance. But also maybe a couple of them, some of them didn't. And so uh, if we go to places like Europa, there's a chance that we might take microbes there accidentally. And I think there will be some sort of process, probably NASA puts, if they're going to be going and trying to look for life, of making sure everything's sterile. But also, that's an important thing to keep in mind, that maybe we'll go there, we'll find something, and it's something we brought.
We find our own microbes.
Yeah.
God.
And the good thing, though, that we have now is if we went and found microbes by looking at the motility, NASA would then go, I assume, I hope, some agency would go and take some sort of device there that could do some DNA sequencing. And now with DNA sequencing technology, we could sequence their DNA. And if they have DNA that we found here on Earth on microbes, which we're building a bigger and bigger database of all these microbes all the time, we would know, oh, that's a microbe we took. Like, we need to keep looking and see if we can find different. And again, this is assuming that all life has DNA. I think that's a good chance that they'll have some version of DNA, maybe RNA, something like DNA or RNA, and so there's a chance that we could then read their genetic material as well. Mm-hmm. I got on a side tangent there.
Wow, no, take that.
Yeah.
That's that's something to chew on for you.
Yeah. Mm-hmm. It's real life,
dude.
Mm-hmm. So lots of things to consider, and you never want to jump ahead of yourself. You're like, oh, we see something, we've discovered aliens. So even if you go there, you can't, unequivocally say we found aliens, new lineage. It'll take years and years beyond just like seeing it in a microscope.
Right. We're all excited to find the alien life. Let's just take our time with it, and not get crazy on that.
Mm-hmm.
That's good. Yeah, we don't want another 80s NASA snafu.
Yeah. I'll try to find that info and send it to you.
Yeah.
I need to make sure.
Yeah. Maybe I can upload it along with the audio of this episode.
Yeah, maybe.
Put it on.
Mm-hmm.
Cool. Well, Carl, can't thank you enough for coming on. This was a blast.
Yeah, I have had a great time. Thanks for having me, Alex. It's been a pleasure.
Yeah, man.
Cool. We'll have to do it again sometime.
Yeah, for sure.
Yeah,
for sure.
I'll talk about anything.
I'll